Hey there, it's Mrs. Marquette. Today we are talking about our last conics section, really our last lecture even of the semester, which is pretty exciting. So the conics section for today is called a hyperbola. So I'm going to zoom in here and just show you what a hyperbola is. A hyperbola, it really looks like two graphs, but it's just one. We've got this hyperbola has two branches, okay? So it's kind of like a graph that either is going to have branches going left and right or going up and down. So the first hyperbola you see opens up and down or opens vertically. The second opens left and right. And if I just look at how this hyperbola is created, it kind of looks like our hyperbola is made of two parabolas, but notice it's not quite as rounded as our normal parabola. It actually approaches these things, these dotted lines that are kind of making an X. Those are called asymptotes. And we remember that an asymptote, I'll underline that here, an asymptote is something that the graph approaches but isn't actually going to touch. So when we actually draw our hyperbolas, those asymptotes are going to help us see like how close we're going to get to those lines but not actually go ahead and touch them. They'll be kind of like boundaries. Okay, then we also notice that we've got this center right in the middle of our hyperbola, and then the vertices are lined up right around that center. So when it's opening vertically, it'll be right above and right below, and we're opening horizontally, we've got the center and then the vertices as well. Okay, so if we go over here, graphing a hyperbola, the big difference in a hyperbola, we already saw what the shape was. The big difference for hyperbolas is that we have a subtraction sign here. Okay, on all of our other graphs, our conics, we had addition signs. So circles was x squared plus y squared equals r squared. Ellipses, we had x squared and y squared, a plus in the middle. Hyperbolas, again, are always going to be subtraction. Notice that I can either have x squared first or y squared first. It doesn't matter, but I just do have to have that subtraction. These numbers, a squared and b squared, those coefficients can be the same or different. Really, the big thing is that you have an x squared, a y squared, and then a minus in the middle. So I'll even write that here. So x and y are squared. And then we have subtraction. Okay, so after that, they kind of tell you what are you going to have for actually drawing out this hyperbola. So we've got some intercepts. We have x-intercepts and y-intercepts. These we draw first. So those values are going to come from our a and our b. So notice that you've got a squared and b squared in the denominator. So in order to find our intercepts, you are going to be doing plus or minus a, and then for y's, you're going to be doing plus or minus b, which is just like ellipses. So we're still going to be taking square roots, finding those values. And then the difference is once you find those values, what we're going to do is make a dotted line box. So we're kind of going to draw something that's not on the graph, but draw this box that's going to help us find the asymptotes. And then after we've done all of that setup work, then we can draw the hyperbola. Here's a big thing. If x comes first, then the hyperbola is going to open horizontally. Okay, so that's going to be, remember that x is always horizontal, so if you see x first, if x is the positive one, you're opening this way. If y is y comes first, then we're going to be opening vertically. So if we've got y squared minus x squared, then it's going to be going up and down. So let me show you just a couple examples here. We have x squared over 9 minus y squared over 4 is equal to 1. So the first thing that we're going to do is graph our points. So our center is going to be 0, 0 for all of these hyperbolas. Okay, you can shift those, but today we're just going to do 0, 0. So then our x points are going to come from that 9. So I do plus or minus, or square root of 9, excuse me, is going to be plus or minus 3. Okay, so that means that the points that I'm graphing are in the x spot, plus or minus 3, and then 0. Okay, so I could even do that right now. I go to the right 3 and the left 3 because I've got that 3 in the x slot. And then for the y's, the square root of 4 is plus or minus 2, which means that I'm going to have the point 0 plus or minus 2. Those are our vertices. So then I go up 2 and down 2. And if this were an ellipse, what we would do is we would just kind of connect those values. We've already done that, but that's not what we're doing. What we're going to do is we're going to make this dotted line box. So I want you to kind of follow the grid lines, and that is what your box is going to look like. The whole point of this box is to draw diagonals. So you're going to go from corner to corner of the box. So notice I'm going from the corner through the center to the other corner. And then corner to corner on this box. It's got to go through those corners. Okay. And those are called your asymptotes. The asymptotes are going to be where your graph actually ends up being graphed. So now I've got two options. I'm either going to have a hyperbola that opens like this, or I'm going to have a hyperbola that opens, oh, and it should hit the intercept, open like this, okay? And the way I can tell is I'm going to go back and look at the equation, okay? So x squared is the first or the positive value. So if I look up here, if x comes first, the hyperbola is going to open horizontally. It doesn't matter which number is bigger, like the 9 or the 4, like ellipses. I'm going to open horizontally, and I'll just put a big H here for horizontal because x is first. So that means I'm going to graph and I might even highlight it just so you guys can see. This is what our graph looks like. Okay. Notice we've got the arrows, which mean that that hyperbola is going to extend forever. And again, even though our 9 is bigger, that's not the reason that it opens left and right. It's because of the x. So for number 2, let's actually go ahead and decide what way this opens before we even graph anything else. Okay, so we've got y squared over 9 minus x squared over 16 equals 1. My y is first, which means that this is going to open up and down vertically. So it's going to look like this. Okay, now to actually get our points, we say 9 is going to be square root of 9 is plus or minus 3. So starting at 0 to the left and right, or actually it's up and down because it's y. Up and down I'll go 3. Okay, and then x squared has a 16, so I do the square root of 16 is plus or minus 4. So then those points are going to be 4 left and 4 right. Okay, so this is 0 plus or minus 3, and this is plus or minus 4, comma, 0. Okay, y spot, x spot. Draw your box. So again, follow those grid lines, actually hit the corners. And then the big thing is to go from corner to corner with your diagonal. All right, now when we graph, we know it's going to be opening vertically. So I'm going to start at those vertical points and make sure you actually hit the vertical points. So this point is on my graph. I'll even change colors. Let's go blue. This point is on my graph. Oh, and it didn't change. Blue. Follow the asymptotes. Again, notice it almost looks kind of like you've got two parabolas. We call them branches. And those branches are just like a little wider, a little more pulled toward the asymptote than typically we see in a parabola. And again, it doesn't matter in this case that our x denominator, that 16, was actually bigger than the y denominator. The reason we open up and down is because y is positive, or y is first. Okay. And just like last time, now we're going to see some problems where I don't have a 1 over on the right side here. Okay, I want that 1 because it's only in that form that I have all of these nice properties. So if I want to do that, I need to do some algebra. So if I want that 16 to be a 1, what I got to do is divide everything by 16. Simplify your fractions and you get x squared over 16 minus y squared over 4 is equal to 1. Okay, now I see that my x is first, so this is going to be opening horizontally. Okay, don't choose which way it's open until you're in the correct form, because that's the only time you can tell. All right, so now since it opens horizontally, I can go ahead and find my box. So I do square root of 16 is plus or minus 4. So that's in the x spot. So starting at 0, 0, I go to the right 4 and to the left 4. And then in the y direction, I take the square root of 4 and get plus or minus 2. So again, that's in the y coordinate, or the y slot. So I go up 2 and down 2. Okay. So I'm going to zoom in here and then draw a little box. And this, again, the dotted line, it's important that it's dotted because this is all set up. Those dotted lines are not actually on your graph. Like if you had your calculator graph this or Desmos graph this, you would not get the dotted line box. It would just happen. Okay, so now we can draw our diagonal. Be careful with your diagonals. Make sure they actually go through both corners and the center. All right, and now we said that we are opening horizontally. So I want to go to the horizontal points, go to a different color, actually graph the horizontal points, and graph your hyperbola. All right, and you can see that you're approaching the asymptotes. You've got those nice arrows that tell me that you know the graph continues on forever, and we're good to go. All right, number 4. It looks right now like I'm going to be a hyperbola opening horizontally, but I want you to hold off on that because what's going to happen, if I want this to be a 1, I need to divide everything by -4. And when we divide by negatives, all sorts of stuff happens. Okay, so I'm going to star this one. I get x squared divided by -4 is negative x squared over 4. -2 divided by -4 is positive y squared over 2 is equal to 1. Okay, so we've got a subtraction sign, but it's kind of like our equation is in the wrong order. So we're just going to change the order. We get y squared over 2 minus x squared over 4 is equal to 1. This is the only time now, since we're in the correct form, that we can tell that this opens vertically. So wait on which way it opens until the very end. Okay, now finding your square roots. The square root of 2 is not a nice even number, a nice whole number, but I can say that it's plus or minus like 1.41. So I say 0 plus or minus 1.4. And then the square root of 4 is plus or minus 2. That one is a nice whole number. So this is plus or minus 2, 0. And again, these are just points that help us to graph. Okay, so we're go start at 0, 0. And then up or down we go 1.4. Right and left we go 2. And then drawing your box, you can still draw your box even though they're not on nice grid lines. Just go ahead and draw the box like so. It's kind of a little box this time. And then make your big asymptotes. Okay, the asymptotes still stretch over the whole graph, even though our box is pretty small. Okay, now we did say that this opens vertically. So I go to the 2 points on the box that are vertical, and those are my starting points for the branches of the hyperbola. This red part that's on my graph, this is actually the only part of the true graph. Again, we're making boundaries with everything that's green, all of those dotted lines, but the branches, those are the things that are really on the graph. Right. So the last two, I would pause the video here, see if you can do these two, and then watch through to the end, make sure that your answers are correct. But otherwise, I'm just going to keep walking through. This has to be a 1, so I'm going to divide by 100. I get y squared over 4 minus x squared over 25 is equal to 1. Notice here that I know it's a hyperbola because there's a minus in the middle. Okay, so I can say First of all, this is going to open vertically. I get the square root of 4 is plus or minus 2. So my points are 0 plus minus 2 because they're in the y-coordinate. And then the x points are going to be square root of 25 equal to plus minus 5. So in the x-coordinate, I get plus or minus 5, 0. Those are just points. No matter what those points are, which ones are big, which ones are small, I open vertically because y is positive. So 0, 0, 0 plus minus 2, and then plus minus 5, 0. Draw the box. You'll notice that every single section that we've done so far this chapter has really just been like a lot of repeat. Okay, I'm going to show you different problems that pretty much have the same thing going on. So these ones, once you get the hang of it, as long as you've practiced, you should do okay. All right, so here I'm opening vertically. So I've already showed you that now we take those vertical points and we just make our branches. So the big thing here is you've got to know what those branches look like. You have to know that those are curved, not looking like a V shape, and they've approached those asymptotes nicely. Okay. The last one is 81 for this number. So I want this to be a 1. Divide by 81. We should get used to always making sure that we divide properly. So x squared over 81 minus y squared over 1. I would leave that denominator. I think it helps. Equals 1. Square root of 81 is plus or minus 9. Square root of 1 is plus or minus 1. So now, what do we do with it? Okay, x is first, so this is horizontal. These are my x points, so I get plus minus 9, comma 0. These are my y points, so I get 0 plus minus 1. And go ahead and graph. So graph your 0, 0. Graph plus or minus 9, 0. And then plus or minus 1, 0. Or 0 plus or minus 1. This is quite the box. It's very skinny. Our asymptotes are going to be a little hard to draw. Just do your best. You're still trying to go through the corners nicely. And since we've got x positive, we want to go horizontal. Again, you got to be kind of careful because these points and these asymptotes are a little hard to follow. Okay, but notice if we would have had it opening vertically, it'd be a big, big, wide hyperbola. But since it's opening horizontally, it's a little skinnier. We've got like closer boundaries for those two branches. All right, so that's all of the graphing for today. Okay, so if I look at all of these graphs, notice we're doing pretty much the same thing every time. This will be on your guide. So x coming first, meaning you open horizontally, y coming first, meaning you open vertically, the x-intercepts, how to make the hyperbola, that will all be there. But you've got to go and do some practice. So make sure you do the practice problems, make sure that you are ready to go on all of that. The last thing I'm going to do quickly is just determine if the graph is a circle, ellipse, parabola, or hyperbola. So just a little bit of review. If we've got a circle, remember that that looks like this. This is always x squared plus y squared equals r squared. Okay, notice you've got x and y are squared, and then the coefficients are the same. You've just got a 1 and a 1, or you could even have like a 2 and a 2, or a 5 and a 5. Then we've got parabolas. We'll go regular parabolas, kind of look like this. This is y equals ax minus h squared plus k. Then we've got sideways parabolas, and then I'll talk about both of those, which is x equals y minus k squared plus h. Okay, notice parabolas. On these types of conics, we only have one thing squared. So if you ever see that you only have like an x or a y squared, and then you have an x by itself or a y by itself, you know that it's going to be some type of parabola. That's a good one to look for. Like, does it have just one thing squared? Then I know right away, parabola. And then we've got ellipse. It's kind of nice to see them all at one time, so you know what you're dealing with. This is x squared over a squared. Y squared over b squared is equal to 1. Here the big thing is we've got x and y are both squared. There's a plus in the middle. And then we've got these numbers. We have different coefficients. So if you ever see different coefficients happening, you know it's an ellipse. And last is what we did today, hyperbola. Hyperbolas are x squared minus y squared with different numbers here. They could be different, they could be the same. But the big thing is that we have subtraction, okay? And those, again, have branches. Forgot to do ellipse. Ellipse kind of looks like an oval. Okay. So those are kind of our guides, what we're doing. I just want to have all of these things kind of together in our review here to see what we're going to be looking for, like on a quiz, on a test, how to identify different conic sections. So I just want circle, ellipse, parabola, hyperbola. I don't care about sideways versus regular. So number 7 is x minus 2 squared plus y squared equals 4. So I have two things squared, so not a parabola. Let's go like circle, parabola, ellipse, hyperbola. So it's definitely not a parabola because both things are squared. Then I look at, there's a plus in the middle, so it can't be a hyperbola because hyperbolas have a minus in the middle. So it's either going to be a circle or an ellipse. This is where you got to look at the coefficients. I've got a 1 and a 1. Since those coefficients are the same, it can't be an ellipse, so it's got to be a circle. Okay, so I kind of go process of elimination with this. Circle, parabola, ellipse, hyperbola. You might notice right away what this is going to be, but I'm still going to go through the process. It's not a parabola because both things are squared. It does actually have a minus. Since it has a minus, it can't be a circle, it can't be an ellipse, got to be a hyperbola. So if you saw that minus right away and you're like, oh, hyperbola, that's exactly what you want to do. Next, we have x squared over 9 plus y squared over 16 equals 1. Again, if you already see immediately what this is, that's great. I know it's not a parabola because it has both things squared. It doesn't have a minus, so it's not a hyperbola. So it's either circle or ellipse. Think about the 9 and the 16. Those are different numbers. So it's going to be stretching 9, or with a factor of 9 in the horizontal direction, factor of 16 in the vertical direction. It's not a circle, different coefficients. Got to be an ellipse. Okay, number 10, y equals x squared plus 2. Notice y does not have a squared. Okay, all of my circles, ellipses, and hyperbolas have both things squared. All right, these are the ones that are like, oh, right away I see that that's a parabola. And then number 11, we have negative x squared, y plus 3 squared minus 5. This one's kind of tricky because it kind of looks like, if I do circle, parabola, ellipse, hyperbola, kind of looks like we've got that minus, so it might be a hyperbola. But notice right now, first of all, I know it can't be a parabola because both things are squared. But notice right now we have my x squared and the y squared on different sides of the equal sign. So I want to move stuff so everything's together. So I'm actually going to move this x squared over and also move this 5 just to get it out of the way. So I get 5 equals x squared plus y plus 3 squared. Notice now I look more like an equation that I can work with. All right, I could even put that 5 on the other side if I wanted. So now it's not a hyperbola because there's a plus in the middle. And then actually both of my coefficients are just 1. So I can get rid of ellipse and it is a circle. The last one, circle, parabola, ellipse, hyperbola, only one thing is squared. Okay, so we know that on a circle I have both things squared, ellipse, both things are squared, hyperbola, both things are squared, so we've got parabola. There will be a whole section on your test that's just identifying. So you've got to go through that checklist. Are both things squared? If so, cross out parabola. Is there a minus? If not, cross out hyperbola. Keep going kind of down the line to make sure that you've covered everything. All right. So that, again, is your last video lecture for the semester. Go ahead and do your practice problems. We will be working, if you're in class tomorrow, we'll be working on our projects. So make sure that you have your sketches done, and I will see you next time.